Hey guys, welcome to the first video in a series of videos. I'm going to be basically looking at using Python and OpenAI and also the open source large language models and seeing what we can do with it. I'm going to start very basic in this video and let's see where it ends up. There's so much going on and it's just a way for me to learn, document, hopefully teach some people and help you guys along the way. Okay, so we can get into it straight away. And with these videos, what I've noticed is that most of the times I just want the code. Like I don't want to watch the video. So it's all in the description. All these three files are in the description. You can go to the GitHub repo, download them, and be up and be up and running. But you know, for the effort, you could hit the like button. That'd be nice. Comment for the algorithm. Toss a comment for the algorithm, and just let it run in the background for those sweet, sweet viewing hours that I need and want and can't live without. And what you'll get out of that is I'm gonna go through the code, explain it a little bit. You know, maybe that does help some people. If you know what you're doing, probably not. Slows you down. So basically, before you run all this, and I should say I'm on an M1 Mac, so everything is ARM native. I'm not using a x86 Conda environment. It's, plug and play. So Conda I'm not going to explain how to do, but basically these instructions will get you set up. This line, all it's doing is you put your Open API key into your bash RC or your ZSH RC file, and you can test it with this command. And the nice thing then is anytime you need access to your key, you just have to import OS and use this line. And then you have your API key without having to copy paste, without exposing it. Sometimes I've made the mistake of uploading it to GitHub and my key was there. So this kind of keeps it safe and is a more convenient way to do it. So this line will basically print out for you the whole model list. So I'm going to skip that. Rather, what I'm going to do is I'm going to print any GPT model that is available to me, right? Some people might have GPT-4 32K token, for example. I don't, you'll see. And then we'll just do a simple completion, right? Describe a fruit, and it'll go through and print those. So we can run that command. It's gonna output what I have access to, basically. And now it's going through and it's damn it. Every time, as an AI, just take it easy. I can describe a fruit in a general manner, right? So that's cool. There's an interesting option. So all the options that you have are sort of online. There's an interesting option they have, which is number of completions. So now if I run the same thing, but I just set that to 3, you'll see what happens. It's going to take a little bit longer. I just thought it would run that same command 3 times. But what it does, it's obviously now a longer response. So I think it sort of chains its responses together when you just increase that number of completions. So now I didn't even ask it about that. So you could probably prompt your way out of this. I'll show you on the next file. So the next file is basically saying that, okay, that's nice, but it's a kind of tedious to have to change this each time and get a response. Nevertheless, you could load in, perhaps if you have a short document, you could read that in and say summarize, right? You don't need the chat interface all the time. So this does have its use cases for sort of single hit function. For example, you could package this up in a function and you don't want a chat interface. But most of us want to see and recreate that, that chat interface. And so that's what I have here. So it's a little bit more, more involved, because if you just put a for loop around this, which you could, right? The problem is it won't have any memory, because each time you could just have the user input this, but it doesn't remember it. And so to get around that, you need to append, basically pile up all those responses. So each time it's getting all those responses, right? So if we run this now, Python open AI number 2. Okay, so I'll just skip this for now in the sense that I'll just say a friendly chatbot does not give boilerplate. I'll explain what I'm doing here, right? Hello, right? So now you can see it's a chatbot. I can test its memory. I can say, tell me about Seneca in 10 words. I just don't want it to go on, ramble on, as it does sometimes. Good. Then I can say, when was he born? So with no memory, it would say, I don't know who you're talking about. And now it knows. It says, okay, he was born in the year 4 BC. I have tried this quit command. Ideally, it should work. Maybe, okay, it should work, but it doesn't. So I have to sort of control C out of it, which is not the nicest. I just got to play around with that. That's your homework. You can make it work and post it in the comment, right? So what I was saying was you can change the system message. So that's the nice thing, right? So what you could do is you could say sassy, sarcastic assistant using emojis and rhymes, right? And then we can run the thing again. So now it won't ask us. I'll say, hello, tell me about Egypt or whatever. Now let's keep it ancient Rome. It's gonna sass me now. Yeah, so it's rhyming using emojis, So yeah, that's pretty cool. Like you can create a chatbot. For example, you could really prompt your way how do you say, you could do some advanced prompting and generate a chatbot, highly tuned for something. You can imagine that you can maybe read in the system message dynamically. We can obviously put that system message to the role system dynamically in the loop, right? So then you could possibly say, if there is a /system command while I'm chatting, it's gonna actually change the system command and change the way the bot acts. And that's much more powerful than saying act as a, so that's pretty cool already. But using this is, it's not so nice. This is not what your grandma will be using, right? If you want her to use ChatGPT, you wouldn't tell her, look, fire up a browser, install packages. She's using C, so she doesn't know about Python. Anyway, so what you can do is you can build an app, and not only is this a app, it's a GUI, right? A browser-based GUI. The nice thing is that it exposes it to the public. Excuse me. So we can hit it, and it'll do its magic. So that's gradio, however you want to pronounce it, sorry. And so we have the URL, the local URL, but it tells you straight away, just do share equals true, and it'll create a public link for you. And so then if we go, actually we can just click on it. What we see is we have a nice GUI, right? And to show it's got memory, hello, tell me about Apetus. Oh, it does its magic. I should have said in like 10 words or something. Yep, great. He already told me when and where he was born, so I can ask, who were his contemporaries? Spelling, I don't know, but I guess I'll understand. So if it doesn't have a memory, it would obviously tell me, I don't know who you're talking about. But Seneca, Marcus Aurelius, yeah. So nice, works. And we can even cross it out. Grandma doesn't have to press Control-C. It'll close it on her end, but of course we have to be pros and hit Control-C till it dies. So yeah, for those of you still listening, that's basically what I wanted to cover today. The problem we still face is that we're appending all the messages. So at some stage, you'll hit the 4,000 token limit, right? If you're playing around with the playground in the API, you'll see that happen. So there's ways around this. You can use vector databases, and you can use LangChain as a way to do this. I've seen some others come up in the last few weeks. So maybe, to try to stay up with all the crazy stuff going on. Maybe I'll do a video on that next. But so next time I want to cover sort of more advanced usages, memory, maybe even chat with docs, something like that, some basic sort of example where we start to do stuff with it. All right, cool. See you guys next time.